Good afternoon, I'm Camden Harp,
And I'm Dan Schwartz.
and this is our fourth and final ME416 project regarding the heat transfer in fin. The problem with this project was to look at a fin that had a 1 centimeter base cooling a 150 degree surface. The fin was to have an approximate infinite length, and we were to look at two different fin geometries. We chose a cylinder and a square. We also wanted to study two different materials, aluminum and copper, and to compare the results that we found using ANSYS to results we found using textbook correlations. So because the fin was infinite, we had to find a value to plug into our calculations and into ANSYS to find the properties. So according to Linehart and Linehart, a fin may be regarded as infinitely long in computing its temperature if m times the length is greater than 5. So we use the equations on the upper left to find m, and then the length that would approximate an infinite pin, and the results are shown below. In order to do the hand calculations, we used a table from Incropera and DeWitt about the fins with uniform cross sections, and this table related the dimensionless temperature, little m, big M, with the temperature distributions and the fin heat transfer rate that we were looking for from these fins.
The results from our ANSYS modeling are shown here. On the left you have a square fin, and on the right you have a pin fin. As you can see, the hot zone is the red color, which is the 150 degrees Celsius, and the blue area is where the fin is cooled down to its lowest point. Here are the results from the heat transfer rate comparison between ANSYS and hand calculations. On average, for both the square and pin fin, they varied by roughly 40%. Here are the comparison for the temperature results in ANSYS and hand calculations. Here they varied by about 20%, and in this case we used just the last point on the fin to make this approximation. So in summary, there was a 40% difference between ANSYS and the textbook correlations for the heat transfer rate, and a 20% difference in the temperature.